Thank you for the introduction, and hello everybody. I've not done an online presentation before, so I've had a few goes and found it quite challenging not to have people sitting in front of you, listening to you, and you don't get that feedback. So I decided that I'm going to create my own crowd here, and I want to show you. Here we've got, let me see if you can see them, we've got Mr. Rabbit, we've got Mr. Bear, and Mr. Sheep. So I'm hoping they're going to be a great audience, and they will probably ask me many questions, and I'll make sure that they're concentrating while I'm doing this presentation. So, what are we going to talk about today? I was thinking of discussing the ABCs of the brain, just the basic way the brain operates, and then try to also explain how things might be a little bit different for tricky kids. So what do we mean when we say tricky kids? For most of it will probably be children that's got neurodevelopmental difficulties. So these would be kids that are struggling with either symptoms or full threshold disorders on the autism spectrum, ADHD, specific learning disorders, intellectual disabilities, tic disorders, and I'll a bit later show you a full list of what we mean when we say neurodevelopmental difficulties. But let's get going. Before I start, I want to just recognize the work of a brilliant psychiatrist from Sheffield University in the UK. His name's Steve Peters. And if you want to learn more about some of the things I'll be saying today, please go to that TED Talk. You can also get his book called The Chimp Paradox. And I have only 20 minutes to explain this to you. You'll certainly be able to learn a bit more about the ABCs of the brain. And obviously afterwards, I will be available for questions. So, we often get tools that's supposed to help us to help children we work with. But we not that often get instruction on how the engine's working. And I think you can imagine that if you don't understand the engine, you're probably not going to be using the tools always in the right way. So to explain to you the ABCs of the brain, I'm going to start off with a little story. Imagine that you hear that there's a sale at Harvey Norman, and what they're selling is a revolutionary machine, a machine that can give you happiness, take away all your worries, give you confidence and happiness and success. I'm pretty sure each and every one of you would absolutely run to go get that machine. So the good news would be that you have such a machine. It's called your brain, your mind. It can do magical things, but you need to know how to use it. And sometimes things don't always go according to plan. So let me put a scenario to you. You're all sitting there, I think, and you are in control of your legs. None of you, I hope, will jump up and run around and then lose control over your legs and sit down again and say, sorry, I had a leg attack. We all have good control over many ways we move and manage our body. But yet, we have feelings that would come and go, and it would feel like we just simply not in control of those feelings, that we are not in charge of those feelings. So my question to you is this: why is it that we have control over our legs, for example, for those who are lucky to have, and then just don't have control over our feelings? And the answer to this question is a bit like an X-Files answer. The answer is we're not alone. There's actually two of you in your head. And this is not only a metaphor, it's literal. There are two different types of brains operating in your head. And I want to introduce you to the second one. Meet your chimp. So, what is this chimp I'm talking about? Let me explain. Deep inside your brain, there's an old part. It's called the limbic system. And this limbic system, it's more or less that center part of your brain sitting over there, is old. It's really old. if you're happy to go with evolution, it evolved first, and then in later years, the cortex became more part of brain structures. And the PFC, especially that part of the brains where we as humans have got a major advantage. So if you don't understand how this chimp is operating, it can make life quite difficult. The job of this chimp is simple, this old brain. So we'll call the limbic system, we will be calling the chimp. We think that one of the major goals of a limbic brain was to communicate. And for those of you who remember your biology well, you will remember that the limbic system is the emotional brain. All our emotions, every single emotion we feel would come from that brain. And imagine how we can use and organize each other if we can show each other what we feel. Take, for example, a dog. A dog can show you aggression and then you know you need to stay away. Or a dog can show you, I want to play, and that will show you, come closer, let's have some fun. So even between different species, we can help each other understand each other through showing these emotions. But obviously that's not enough. You cannot communicate at a high order level by just using emotions all the time. So the cortex arrived. And it added many new dimensions to the brain. And I'm going to try to explain to you these different sections of the brain, first in a complicated way, and then we're going to go a little bit easier. So there's 6 parts of the brain that I want you to have a look at. Those are the parts, and let's use an example to understand how they would work. So let's say you are at a dinner party with your family, and a friend would come and whisper in your ear and saying, your mother-in-law just said that your famous chocolate cake that took you hours to bake just tastes like tarmac. Here's your brain reacting. The first bite would come from the limbic system, and specifically a little part called the amygdala, and it will say killer. But very fast after that, luckily we don't stay with that, another part of your brain will come online, the orbitofrontal cortex, and this part of the brain would say, whoa, 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 stop, stop, don't kill her. Let's just be a little bit more socially aware. We can get even in a more devious way, maybe. And just after that, the uncinate fascicularis or the uncinate fasciculus will jump online, and it would say, whoa, 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 let's just get some harmony between these first two parts of the brain. This is the part of the brain that helps us to have a bit of conscience and guilt, and often the part of the brain that's implicated when people has got a disorder called psychopathy, where they don't feel empathy and do real bad things. And just after that, the dorsolateral prefrontal cortex will come on board, and this is a part of our executive functions, and it's really helping us to think and helping us to stay calm, and it's there to override emotional biases. And it would say, hey, let's stop. Let's just look at the facts and look at the evidence as what's happening here. And just after that, the ventromedial prefrontal cortex will come on board. And this part is all about empathy and compassion. And it will maybe say, why is it about me, me, me? You know, my mother-in-law has for years been baking chocolate cakes. And maybe now I'm taking a position, and maybe it's really understandable that she's feeling a little bit upset now that I'm baking chocolate cakes for the family too. And then obviously there's the cingulate gyrus, and this is just memories that would look at what happened in the past, you know, what will happen if I get aggressive, what will happen if I act with kindness, and weigh certain options. So, how can we make it simple? We can make it simple by dividing the brain into 3 bits. First of all, the frontal lobe, that will be you. Next, the parietal lobe, and these are all the other things that we stick together, all the thinking and the memories. And then there's the limbic system. And to make it even easier to remember, we can do this. We can call the limbic system a chimp. We can call the rest of your brain the computer, and we can then look at the frontal part and we'll call that the human. So this is what I got from Steve Peters, a lovely way to look at the brain. So how would these parts work? First of all, the chimp. The chimp is all your instincts and drive. This is your feelings, your emotions, your impressions. It will give you worries. With it is the amygdala that gives you that fight and flight response. And this is a survival machine. Over the years it was there, developed, and it kept us safe. And then there's the computer. This is just a part of your brain saying, hey, I'm here. Use me as you like. And it stores all data that's accessible for you and the chimp to use. and you can also influence what's in the cortex. You can save things into that computer. And then lastly, there's you. This is your prefrontal cortex, and this is the part that gives you rational thought. It works on facts, truth, and logic. Now, there's a big problem. The thing is, the chimp doesn't like the new arrival, the cortex. And it's thinking that the cortex is taking over its job. So it fights the cortex. And again, not figure of speech, literally. It's got little things called neurotransmitters that it will release in the blood to shut down the frontal lobe. And this is what we do when we get angry and don't think and do something stupid and have to go back afterwards and say, hey, that wasn't the best thing to do. So, problem also is that this chimp is 5 times stronger than you. So when it gets into play and emotions are out, it will take over. It's got another trick. It can put little gremlins and spam into the computer that would affect your thinking, and it will bias your response towards that what the chimp would like. And obviously, if you're going to get hit with a brick with 30 neurotransmitters shutting down the frontal lobe's chances to influence your decision making has been compromised. So let's use a little example. Here's Johnny. Johnny walks inside the room and he sees a plate of biscuits. Just looking at it, it will hit the thalamus and will immediately send a message to the chimp. So the chimp gets the message first, the first bite, and the chimp will say, hey, take a bite, take those biscuits, eat it. And then you will say, hey, wait a minute, maybe somebody else would like some too. And immediately the chimp will hit you with a brick, release those neurotransmitters, and you'll gobble up all the little biscuits. Now, after a while, slowly, you will come on board and then you'll start to feel guilty. By then it's too late. So how can we change this process? Well, what happened is that the chimp has placed little gremlins there saying things like, if you don't have those biscuits now, you won't have them ever. And those thoughts created a bit of bias towards the chimp. But if we can program that computer better, when the chimp would go there and find scripts like, it's really important to keep my relationships good with the other people. It's really important that I keep my trust good with mum. And all those thoughts can stop the chimp if it's loaded up well. And that is more or less what we're going to be looking at. So, how do we fix this? What can we do? Now, the first thing you need to do is to work out who's in charge. Now, as I'm going to go, I'm going to explain to you how kids with neurodevelopmental difficulties might find this process hard and what we can do to help them. So this requires self-awareness, and this is something we know kids with neurodevelopmental difficulties would struggle with. Self-awareness would ask the question, who's in control here? Is it the chimp or is it me? But if you don't even know that you've got the chimp sitting there fighting you, you know, this is almost impossible to do. And that's probably the main benefit from today, is to become aware of this little thing in your head called the chimp. So how do you know who's in charge? There's a few ways. First thing is ask yourself, do I want? Do I want this feeling? Yes, then it's probably you. No, it's the chimp. Look at the long-term benefit of what's happening. If you ask the question about the long-term benefit of what you're doing and you're seeing, oh, well, it's not in my interest in the long run to do what I'm doing right now, it's probably the chimp. Good. So you can also ask yourself, if I have a bit of time and I reflect back on what I'm doing, would it be best for me to do it? And if the answer is, well, no, then it's probably the chimp. Cool. And then you need to look at the problem. You've got to first work out whether this problem is outside your head or inside your head. Inside your head is what I want to talk about today. Outside your head means it's a practical problem, like there's a truck coming at you, and then you need to just do a thing called problem solving, but we're not going to talk about that today. Let's look at what's happening if the problem is inside your head. Cool. Wrong way. All right, so if the problem's inside your head, you need to know the chimp is busy with its tricks, and it's got 3 tricks that I want you to know about. And each of these tricks are all about the chimp fighting the prefrontal cortex, you, to try to get control over what's happening inside your head. The first trick of the chimp, and you'll know this very well if your parents are working with people with difficulties, is avoidance. Kids just would not want to do things that we know is good for them, and especially looking at the long-term interest. So, avoidance is an amygdala function, fight, fright, freeze. It helped us long ago, for example, when you had to pick a fruit and eat it, and you don't know what the fruit is all about. 100,000 years ago, not all fruit were known. A human would say, no, I'm not going to eat it, I don't know what it is. It's an avoidance response. Or there might be a cave, dark cave. Again, the human will approach the cave and say, I don't know what's in that cave, and avoid it. And that was a survival response. So those who were careful survived. And we're carrying their genes today. So, today still, the brain would do it. The amygdala will give children avoidance responses. Special needs kids, let's take for example, autism spectrum disorder kids, got a bigger amygdala. They are more likely to avoid. So bad that there's a thing out there that's called pathological demand avoidance, which is really part of neurodevelopmental disorders, but some people are campaigning that we should make it a separate disorder on its own. Anybody working with kids like this will know how they avoid. So, I'm not going to show you these videos. I've worked out that there's not enough time, but it's just all about how animals would avoid things that they should be not avoiding, just to show you how it works in nature. The fix for this is laddering. What you want to do is you want to take that task after you've calculated that it's important to do it. If the child's avoiding a snake, of course, that's a good, appropriate behavior. But let's say that the child's avoiding school. You want to use a technique called laddering. Small steps at a time, a systematic desensitization process to work towards it. I can give you many examples, but there's no time today to do that. One thing that I want you to know is that typical children and children with special needs has got these two lines. A flood line, this is where you push them too far, and an avoidance line, this is where you don't extend them and they don't try something new. And you'll see on this little graph that the flood line for children who are typical and the avoidance line is a little bit more further apart and it's a bit more stable. But for kids with special needs, especially autism, ADHD, those kids, though, that gap is small. It's so hard. You're just over the avoidance line and then you hit the flat line. So to stay in between those two lines, really, really hard. But we need to be aware of it so that we don't push too hard and think it's just a matter of pushing them because it ain't going to work. But also be careful not to extend them. So a really tricky job we have to stay between those two lines, but good to know that they're there. So, second trick of the chimp. The chimp likes to take over thinking, and it's basically doing a thing that we call what-if thoughts. For kids, we call it just what-ifing. So these are little fast and irrational concerns about what might happen. And usually when we do these what-if thoughts, it links up with avoidance responses. So it's a what-if thought and an avoidance response would go together. That's the second trick of the chimp. What do? We want to slow down thinking. We want to force cortical involvement, and we want the child to think of three scenarios. What's the best, what's the worst, most likely outcome? And we usually do that to ask the question on a scale from 1 to 10, where 10 is Armageddon, how bad is this? Would be one way of trying to look at the outcome. What's going to happen if we do this? And usually we want the child to acknowledge and go towards the most likely outcomes. The third trick is Thoughtholes. A bit more tricky because this is about a thing called metacognitive errors, which could be tricky, but if I give you examples, you'll understand it. This chimp might sometimes put a few gremlins into the computer, and this would affect the way you think about things, and the examples will make it clear to you. This is when people do things like all or nothing thinking. If I'm not perfect, I've failed. Or mental filtering, where they notice failures but not successes. Overgeneralizing, saying, hey, it will never be good at this school for me. It will always be like this. Or not looking at the positive, discounting positive things. Jumping to conclusions, mind reading. I know that teacher doesn't like me. Or fortune telling, this is going to end bad. Emotional reasoning. Because I feel bad, things are bad. Because I feel anxious, things are dangerous. Magnification or catastrophizing, we call it also gigantifying for kids. A big one. This is where small problems are turned into big ones. Should and must thinking. I must do this. I should do this. Labeling themselves. I'm stupid. I'm a loser. Or sometimes personalizing things, thinking everything is your fault. So these processes are called cognitive errors. And the chimp loves using these cognitive errors to create a role for itself in your head. Good. So for kids, we've got different words, and we've got to be careful how we explain these things to kids. So Gozen's a beautiful program that helps us understand metacognitive errors a bit better. Words that they use there, keyholing, this is when you look at only parts of the evidence, leapfrogging, this is jumping to conclusions, or gigantifying when you make things really big. There's also extremifying when you use words such as never and always, and reasoning when you go, because I feel anxious, this is dangerous, or things must be bad because I feel it's going to be bad. All right, so how do we fix it? This is where CBT comes in. And what we want to do with special needs kids is we want to break it down into small little steps, ABA style, for those of you who's aware what ABA would mean. So we use a thing called the 5 C's. You catch, you check, you collect, you challenge, and you change. So what we do is we want the child to first catch the thought, then check for a thought hole, then collect evidence. Is this really accurate? Then start challenging themselves about the accuracy, and then change, putting a statement out there that we call is optimistic and realistic. Cool. So there's just a short summary. Go catch, check, collect, challenge, and change. The 5 C's. All right, so the secret really is to program the computer and manage the chimp. The secret is for children to manage, and the goes-in problem, the goes-in program calls the chimp Widdle. So that's their name, American name. I know here it means something else. In essence, promoting what we call frontal-imbic activity. So this is the frontal lobe controlling the limbic system to self-calm, self-soothe, and self-moderate through how we think. Okay, a few things though that you need to know is that with complex kids, things ain't always that easy. And with complexity, as I've explained at the beginning, we mean neurodevelopmental disorders, and there's a few of them: the intellectual disabilities, the autisms, the attention deficit hyperactivity disorder kids, also kids with DCD, specific learning disorders, tic disorders, those things. Now what I want you to know is that these kids have problems within usually their long white fiber tracts in the brain. So what they'll have is they'll have a highly concentrated bundle network that will give them special abilities sometimes. This would be, for example, remembering the whole dictionary. But then if they have to integrate that with other areas of the brain, they can do it, but not as well as typical kids. So I know the whole dictionary, but I have to order lunch. To do that at a restaurant, I need to integrate my words with a social setting, and then I struggle. So these long white fiber tracts create a gap between the different areas in the brain. It's the same if a storm would hit Tassie. You know, it's more likely that it would take out longer roads than the shorter ones. A cul-de-sac would probably not have damage, while somewhere between here and Hobart we will have a bit of damage in the road. If you look at ethology, how autism spectrum disorders and ADHD develop, it's usually there's a bit of a storm happening at the 3rd trimester. A mum might have a bit of flu, and it creates a problem with the connections in the long white fiber tracts. I cannot explain that in full detail today. And we know this because we can image the brain using new techniques such as DTI, which is the beautiful image that sits on your right. So what you get is you get this meat cleaver disconnecting the things of the frontal lobe from the chimp and the computer. So what you see then is that it doesn't matter what the child knows. I mean, you teach them things, but they don't use it. The frontal lobe is where we put the things that we know into play. And the parietal lobe at the back is where we acquire knowledge. So this separation makes it hard for the child to use the knowledge they know. And it makes it hard also for the child to manage the chimp. So we need real special techniques to control the knowledge in the computer and to control the chimp. And that's why it's so important that you engage your child with a psychologist who can teach you these techniques. Good. So the CBT component is an evolved ability for humans that will come later in life. In the beginning, children would self-regulate through touch and hold and sucking or rocking or movement. Later, they start to use distractions by breaking attention away. This is when we got a child and say, hey, look at the little sheep, when they're upset, and say, look at the little sheep, and slowly they will stop focusing on what they focused on. Or we can just layer. We can say, oh, you've hurt your knee. Here's an ice cream. So you basically slap a good feeling on top of a bad feeling. And this can work for adults too. But usually what adults need to do, what adults would do is to try to restructure the way they think about something. The appraisal system needs to change. I'm going to look at this problem a little bit different and look at the positive about it. And that's how we calm ourselves down. So, to recap, you're not alone. There's a chimp in your head. He can be your friend and must be managed. The chimp has got 3 tricks it avoids, and to fix that, we need to use laddering. We can also help the chimp to stop asking what-if questions, and the way we do that is to use the 3 scenarios. What's the best, what's the worst, and what's the most likely. And lastly, the big thing, thought holes, cognitive errors. We fix it using the 5 C's. Go catch, check, collect, challenge, and change. We've got to talk to our chimp. We shouldn't ignore it. That's my alarm saying I better stop. So, right on time, I want to tell you that I wish you and your chimp a really good day and a happy life. Thank you.